and I'm very glad you guys have shown up. Susan, hi to you. Susan has been with us. Cape Korea Brian has been with us. Emma has been our coordinator, but she's currently feeling unwell, so she'll just be attending. Then we have Jeremiah Katumo. Today is present. He'll do presentations. I'm very glad my brother is here. Then we have Gift. Gift, I think this is the first time. Welcome. Okay. Thank you. That is enough of that. Now we'll begin. Okay. I'm about to share my screen with you guys. I'm going to share the screen about the presentations that we have made for today's session. And guys, remember, we're operating under 40 minutes in every session. So our meeting might end in a few, but you guys, you can still click the link and rejoin. So when this is cut, don't go offline. You can still press the link and get back to the meeting. Okay, now let's begin. Let me open the other, not this one. Today we are to present. Welcome to today's session. I hope everyone can see my screen. If you can see my screen, please just type on the chat, or you can raise your hand to confirm it. Thank you, Gift. Thank you. I think we can all see the screen now. So today we are going to discuss about data analysis, and we are going to use R. Okay. In the previous sessions, we have learned about R fundamentals, and we discovered that R is a free software that can perform a variety of tasks. And now we'll dive into data analysis. So someone might ask you, what is data analysis? Okay, let me just give you a crunch of it. Data analysis is basically a field of science or technology that deals with extracting insights from raw or unstructured data. You're given some data, then you try to come up with insights from that data. That data is not organized. You are the data analyst, you're going to organize it very well. Then you're also going to get insights from it that someone cannot see with his bare eyes. You have to run some program to get some output, which will now be your insights. So basically that is the meaning of data analysis. And those are the tasks involved in data analysis, gaining insights from raw data. We can read it from here. We can say data analysis refers to the process of collecting data, processing the data, cleaning the data with the aim of getting new insights regarding a certain phenomenon. Remember, we have said a certain phenomenon. That means you have some problem you want to research about, then you're given some data, then you gain insight from it, then that will help with the decision makings if need be. Then I also said here, many data practitioners have different definitions regarding the topic, but the common ground is that data analysis is a step-by-step process aimed at gaining new information from data. This new information shows trends, provide answers to certain problems, or improve the decision-making process. Okay, I think now you're familiar with what data analysis is. In case you might forget, just remember, it's aimed at gaining new information from raw data. Okay, then we'll proceed on steps involved in data analysis. Remember, we have defined data analysis as a step-by-step process. That means there are numerous steps within data analysis that an analyst must partake in order to gain some insights from raw data. And we said some of the steps involved here are data collection, data wrangling, data cleaning, EDA, which is AKA for exploratory data analysis. Then we have analysis itself. Remember, analysis can be in many forms. We have correlation analysis, regression analysis. It depends on the problem that you have at hand. Then we have data visualization. Then we have report writing. Remember, I told you in the beginning of our sessions that there is the communication bit. When you're doing your research, you have in mind, I'm going to communicate my findings to this group of people, your targeted audience. So you can do reports, you can create dashboards, and whatsoever. We'll discuss them. Okay, so in today's session, we are going to discuss these topics specifically. We are going to discuss about how you can set up your R working environment, how you can install R libraries or packages, how to import data into R. Then we'll do exploratory data analysis, we'll do data cleaning, then we'll do some data visualization. Remember, exploratory data analysis, we'll define it later, but it also includes partly data visualization. Then I see we have 6 minutes remaining. 6 minutes, yeah, I can cover something with that. Maybe I can show you guys how to set your working directory. Let me share my R screen. And today, guys, we are going to be two presenters, me and my colleague, Jeremy. I'll take you through, then he'll also take over. So let's see how you can set your working directory in R. First, you can run this line of code, which is getwd, which simply means getting working directory. Let me clear these ones first. So if you run getwd, which means get working directory, it will take you to your current working directory. That means where your R program is currently running from. So it's a good practice to set your working directory because it makes your work more organized. In other languages, we can say setting up an environment, but we are setting working directory here in R. So to set work directory, you set wd, then inside you place the path. Path simply means this one, like this one here, from your computer. So let's say I want to set it from my desktop in a folder called, let me do that. Let me create a folder first, then we share with you guys. Well, I'll share this screen now. On desktop, create new folder, new folder. I'll name it data sessions. Okay, there is a still data session. I have a data session folder here. So maybe I can say I can replace it, or I can just use that one. So I have a folder named data sessions on my desktop. Then you come here. Let me show you on screen. Let me show you now on. I've copied my path, and this is how I'm going to bring it on my working directory. Remember, these should be / from backslash to /. Control enter. That way you have set your working directory to this new directory. So we can say get wd to see our current working directory. If it's set to data session, then we're good to go. We know that our directory has been set successfully. You can see on the console, the direction was set successfully. Okay, guys, that is how you set your working directory. So what you can do during your free time, you can practice this. You just set a file, a folder on your desktop, then you can insert files from whatever folder, then you can run it on R. You'll see the outputs. We're having 1 minute and 57 seconds, guys. So maybe any questions up to there? We're going to take a minute break, then we are back again. People got late to this, but there is no problem. We'll still cover everything up to what we intended to cover today. So guys, please, after this, just get back to the meeting. It's not over. We're still working on it. Thank you. Any questions, you can write them on the chat box and we'll continue after this 1 minute break. Any question? Any question? Okay, I think that was easy. Everybody understood that. We'll be back in a few, less than a minute. We'll upgrade. Don't worry, guys, we'll upgrade. For now, we work with whatever is there. Welcome. Okay, so we have seen how to set our working directory. So our next step will be to learn how to install packages in R, installing packages or libraries. So to install packages in R, we have said here, you'll use this command. You'll say install.packages, then inside your brackets, you'll place the package you want to use. So in data analysis, some of the most common used packages are tidyverse, ggplot here, tidyverse, we have ggplot, tidyverse, ggplot, and dplyr. So we'll go ahead and install them. Let me show you. Okay. Install packages. Let's say I want to install ggplot. Ggplot is mainly used for data visualization. The current version is ggplot 2, so we'll run that. Oops, my system is currently loading some other packages, so I'll give it some time. Basically, that is how you install a package. You call install.packages, then inside your brackets, you define the package you want to use. And we have said some of the most common used packages for data science are tidyverse. We have ggplot, and version is there. Then we have dplyr. You'll see other packages and you'll use them depending on what you're trying to execute. So I've said to install them, you call this command. Then after installation, you have to load them inside your workspace. To do that, you call library, then inside the bracket, you call the package. So for instance, let's say I want now to load my ggplot2. ggplot2. That is how I'll load it. Let me try to run it again. I think, oh, my environment is still busy. I don't want to restart my R. It will take so much time. So that is how you install a package. You can also do install. I already have them in my system, so that's why I'm not worried that they're not installed, that they're not installing. But for you guys, if you have not installed them, this is the process. Okay, let me say I want to download tidyverse now. That is what I'll run. I think it's free now. You can see tidyverse is loading. And guys, this tidyverse package, it comes with a lot of libraries of R. Say now we want to load tidyverse. Tidyverse is already installed now. Let's try loading it. I want just to show you some of the libraries present in tidyverse. You can see here on the console window, it has attached some of the libraries within tidyverse. We have tiboo, we have tidyr, we have par, we have stringer, we have focus. You'll know how to use these as time goes. Then let's install dplyr. Dplyr will basically help us to perform basic data manipulations. Like you can select, you can filter out your data, you can group by. Those are some of the common terms you'll be hearing throughout this course. So we have installed packages, dplyr, then we run. Oops, it's still running. I don't want to restart this. but I think I already have it installed. But this is the process on how to install dplyr. Then that is how you load it into your workspace. Okay, so that is how you basically install and load libraries inside your R Studio. Let's proceed. So libraries, what they help you with, they make your work easier. They are like modules or functions. They're written in R, then they are collected together. They can perform some specific task. Like I've explained, ggplot is basically used for visualizations, dplyr for manipulations, tidyverse, it's a collection of various libraries now. Okay, now we'll proceed to discuss on how to import your data files into R. Remember, we are trying to get insights about some certain data. Therefore, we should learn on how we can import those data from other sources into our R Studio. I'll show you a simple way to do that with an example. Remember R, before you proceed, remember R can use data from various sources. That means it can use various files, types of files. We have CSV files, XLS, subfiles. Subfiles are from SPSS. If you're familiar with SPSS, those who are doing statistics, I know you have studied about SPSS. We can also handle that, but someday. It's not a difficult language. It's just a point and click programming language. Then we have other files. We didn't list them here, but R allows for various file types. So for our session, we'll be using CSV files and XLS files. I think we are all familiar with these types of files, CSV, XLS. These are from Excel and Google Sheets. So let me show you how you import your data into R. Okay, let me clear this. I'll come to this environment pane here. You can see there is this place written import dataset. If you click that, it brings for you options of which data type you want to source to your R Studio. You can select this and see the options it brings. If you select that, for instance, you can see it reads CSV. This means it reads CSV file. So let's take, for instance, I have a file from my computer, this one. Or what I'll do, I'll first copy this data into my working space, not working space, but working folder. Remember we said we did setting working directory. So what I'll do, I forgot that, I'll take this data to my current working directory. Then we'll work from data sessions folder. That folder, you can copy, then come to desktop, data sessions, paste it there. Then we can open it from this. Let's cancel this one first, then browse. Come to desktop now, our current working directory, which is data sessions. Then we choose insurance, then we open it. You can see, it gives us our data here. Then you click import to make things easier to read from your working window. We can copy this code. You see copying. For copying, you can just cancel this. Then you can forget about this one now. This was just for, I was preparing presentation also using this. Now we can copy that, read insurance.csv. Then if you run this, you'll see here your outputs, not outputs, but the data. The data has how many variables? We have age, sex, BMI, children, smoker, region, charges. This was an insurance data. Okay. So for instance, we did set this working environment. If we did do that, we could have come here, then insert the working directory that you want to source your data from. Say for instance, now this is our working directory. That is how you would have defined it. Then say head is equals to true. Then separation is equals to comma. But this is not a must. This one you'll use if your data maybe is semicolon separated. You just specify the separation technique in your data. So we won't use these because we already have set our working directory. So we'll have only that remaining part. Okay, so that is how we import your data into RStudio. I can repeat that. You come here on environment, choose import dataset. You can choose from this one. This one will take you to CSV. If you choose from this other one, let's say you have taken from Excel, it chooses files with XLS data types. It's XLX. Yeah, that is what you just come here, browse, select your file from whatever it is, then it will be loaded here. So that is how you import data into RStudio. We will proceed. Let's see what our next slide says. We'll share these slides and we'll also share the codes. Today, we didn't include every code in our presentation, but it will be sent to you guys as a code file. Anyone who has a question can just write it on the chat box. We'll read it, then I'll attend to it. Let's proceed now. Okay, after you've imported your data into RStudio, the next step is to explore your data, know what your data is all about. So, by definition, we can say exploratory data analysis is used by data scientists to analyze and investigate data sets and summarize their main characteristics, often employing data visualization methods. So, using EDA, you can get some characteristics, which are the major characteristics in your data. You can also use data visualizations to show these characteristics from your data. These are the most common commands used to find some insights. If you use head, then you specify your data, then n is equals to, this will output the top entries in your data. So let's say here I write 10. I'm working on slides. So if I write 10, the output will be the top 10 entries from my data. Then tail, similar story. So let's do them practically. We'll do this. I'll do them as I explain. So we'll start with head and see what it has. Exploratory data analysis. Yes. So let's try to output the head, the top 10 entries for our. If you just run with it without this n, let's first run it without this n and see what it outputs. Let's place our data set was called insurance. Let's say it's insurance for this case. If you run this, it gives the first 6 entries in your data. You can see on the console, this is the output. It gives you first 6 entries. So maybe someone might ask you, list for me the top 6 values in that data set. You can do that. If you run head, then you insert your data set, it will output that. So let's specify something. Let's say we want the first 10 top entries. You'll say n is equals to 10. Let's try run that. You can see from the output, we have 10 entries now from 1 to 10. So that is how you can use head, tail, similar story. If you do that, then delete, let's delete this other part and see. It returns the last 6, the bottom 6 entries in your data. Okay, if you specify, let's say n is equals to 5, or let's still use 10. It specifies the last 10 entries in your data. Then there is this other technique you can use, which is encall. Encall, basically what it does, it highlights the number of columns in your data. So if you do encall, then insert your data set and run, it tells you the number of columns or the number of variables in your data. So as you can see, it has said we have 7 columns in our data. Let's confirm that from this pen. We can see we have age. Let's confirm from this other one. It's clear here. Yes. You can see we have age, that is 1, sex, BMI, children, smoker, region, and charges. Okay. So that is how you know the number of columns in your data. We can also know the number of rows by using end row, then insert your data frame. If you run that, it tells you the number of rows in your data, which is, in our case, is 1,338 rows. These are the number of rows in our data. Then there is this other exploratory data analysis command, which is str to mean structure. If you use this, it describes the structure of your data. It will basically give you some summary. So let's try it out and see what it outputs. We are still working with insurance data. You can see these are the outputs when you call str insurance. It tells you a variable, its data type. You remember we talked about data types earlier on. So let's take, for instance, age. Then the data type here is numerical, sex, character data type, BMI, numerical, children, numerical, smoker, character, region, character, charges, numerical. Then it has also give us some details here. Above here, you can see 1338 times 7. This is the number of rows versus the number of columns. You can see how structure makes our works easier. You don't have to run a single line of code every now and then that when you want to get the number of columns or the number of rows, you just do structure and it will give you the shape of your data frame and the class each variable belongs to. Okay. Then we have this other command, which is names. Names basically will give you the names of the columns. Let's say now insurance. If you run this, it will give you the name of your variables, which in our case here is age, sex, BMI, and charges. When you do summary, what it does, it gives you some descriptive statistics about your data. It will run for numeric data, I think, but I think it will run for both numeric and categorical. Okay, you can see this is the summary statistics for our data. Summary statistics, we have said, it outputs the descriptive statistics of your data. So for instance, here we have age. It has given you the minimum value for age, which is 18 in our case, then the first quartile, which is 27, then the median, which is 39, then the mean, then the third quartile, then the maximum age in our population. Then you can look at the variable sex. It has identified it as a character of length 1338. Then BMI, you can see the minimum BMI. BMI is the body mass index, I think, body mass index here. We have the minimum, which is 15.96, first quartile up to max. Then we have children, similar case. It's a numeric data type, so it will give all these descriptive stats. Descriptive stats, we have the measures of central tendency is here. You can see median and mean. Then we have first quartile, third quartile, which are, I think, measures of dispersion. That is how summary stats work. So understanding this is very, very crucial, because if you want to understand how your data is, the outlook of your data, you'll have to run this summary. From this, you can now decide on what tests you want to run. Remember, we have hypothesis tests, we have analysis, but we are going to major on analysis. Those other ones are for statistical concepts. Okay. So that is basically how you can perform exploratory data analysis. Using other functions that we discussed earlier on, you can also perform exploratory data analysis. The functions that we discussed on Tuesday. Okay, we'll proceed now. We have seen on how to import our data and how to do exploratory data analysis, but it's not over for exploratory data analysis. We'll also look on how to do exploratory data analysis using visualizations. Let me look at the slides. Yes, exploring your data using visualizations. This is our next subtopic, which I've said you can use graphs to show some insights about your data, to find patterns, to communicate trends. Yes. So here I defined it as data visualization. If you read, it refers to the use of pictorial aids such as graphs and charts to communicate some of your findings from the analysis. Visualization often tell the association between variables or the trends and patterns within the data. Okay. So, and in visualization can fall into the following scopes, depending on what trends you ought to find from your data. You can have univariate visualization. So univariate visualizations, these are visualization where you aim at finding some trend regarding a single variable. Let's say you want to know about the age of people, the distribution of age of people who attended that study. You'll use univariate visualization such as the histogram. Say you want to find the distribution of gender of people who attended that part of that study. You'll use something to do with bar plots. Then we have bivariate visualizations. Bivariate visualizations, what you do here in by compares to two variables. You're doing comparison for two variables, or you're trying to find the association between the two, or to plot the patterns. So some examples of bivariate visualization might include a scatter plot. You remember scatter plot. In plotting a scatter plot, we have X entries and Y entries, where we try to compare those two entries to find if there is a change in X, what is its relationship to the change in Y. This one we'll do for numeric. Then we'll do, using scatterplot, we'll do bivariate visualizations for numeric data. Then we also have, I think, stacked bar chart. You can use stacked bar chart to show bivariate visualization relationship between two variables. And then we have multivariate visualization. This one you'll use more than two variables in a single graph. To find the code describing the visualizations, you'll just click on this code. It will take you there. But for now, let me write it out. Okay. Are we all together? Please, someone confirm. Just raise your hand and I'll know we are all together. Can you all hear me? Thank you, Susan. Klaus, welcome. Klaus, welcome. Okay. So far we have handled how to import our data into R, and we have how to set our working environment and how to do some exploratory data analysis on our data. I've said for exploratory data analysis, you can use visualizations or you can write some functions. And I've said that the ones that we have discussed here are not all the exploratory data analysis commands. You can use other functions that we described in our earlier class. But for today, I've described on how to use structure, how to use number of columns, how to do a summary, about how to discuss your summary statistics. You've said summary statistics basically gives you the descriptive stats. The measures of central tendencies, the measures of dispersion, you can show them using summary stats. Those stuff. So I can see we have 8 minutes and 55 seconds. I think I can do one visualization and explain it, then we'll get back after those 8 minutes. After this time is up. So I'll start with the univariate. I'm looking for some data that I can use that has many entries, so I can show you. Let me see if I can work with. Okay. I'll jump to this. Okay, I want to use some data here called marriage. I'll show you how it looks like. So marriage is found within Mosaic data library. So in R, when you're practicing, you can use some data that are already inbuilt in libraries in R. Remember, we have discussed about libraries also, about packages and how to install them. So for now, I'm going to work with some data called marriage. It's in Mosaic data. This is how you can load it in. After installing the package and calling it, this is how you can work with it. Now let me load it, library, then Mosaic data. Mosaic data. I've run this one, so there is no need for that. Let me just load it. I've loaded it now. Then I'll also need ggplot2. Remember, I told you guys, we use ggplot visualization. That is the work for ggplot2. Let me load it also. Okay, now I have my libraries installed. I've said this Mosaic data, it's where I'm going to fetch my data. Then ggplot is what we're going to use for visualization. I chose this data because it has many entries as compared to this insurance. But the same techniques that we are going to use here, you can use them on any data set and you'll receive outputs. You can later on go and try working with your own data set. You can download data from, there is these open repositories. You can use Kaggle. We have another one called UCI and many more. You can also use data from WHO. They have their version of free data source. You can download from there. So let me call this, call it, then we can view this data. You can see this is the data from my console. You can see this is the data. It's a big data. You can see we have book page ID, update, ceremony. So remember, we said to know the names of your columns. You can call names, then the data set. Oh, this is already here. You can read it from here. I think the package doesn't highlight them properly, but the good thing is that we have it in our workspace. Now we can work with it. Let me try to be fast before the time cuts us. So we'll use ggplot to plot. I've said we are going to start with a univariate graph. A univariate graph, I've said, it does show the patterns in a single variable. So I'll name this as univariate graph. So for our first case, we are going to use categorical data, which is race. Then we are going to plot a bar graph. So using ggplot, this is how you plot. You first define ggplot. Inside it, you insert your data. Then aesthetics. This simply means the X and Y axis. Since we are working with a single variable, we'll assign it a single entry, which is now race. We want to know the races of these people in our data. Then geomba. So let's try run that and see the output. You can see the output here. Last time I told you guys, this is where you'll be receiving your plots from. So we can zoom this. Hope you're all seeing. This is our bar plot. We have plotted a univariate graph to show categorical entry, which is race. You can see American Indians are few. We are now into data analysis. Using these graphs, you can now give some insights about your data. You can say in my study population, whites were the majority. Using these bars, you can see this has the highest frequency, followed by the black people. Then we have Hispanic, then we have American Indians. So that is how you do a univariate bar graph. Okay, so there is some tricks I want to show you guys. You can use this plot, but it doesn't look very appealing. So you can do some stuff like using different colors here in these bars. You can also name. It's a good practice to name your graph to make it easy to understand. So to do that, I'll still use this line of code. First, I want to use a different color. So to use a different color, you say fill is equal, then you define the color you want to be in your graph. I'll use cornflower blue, blue color, cornflower blue. Then after fill, I want these borders. I want the borders to be seen clearly. I want them to be black. There I can say color. I can say color equals to black. Now let's try and run that. You can see my new graph. My new graph now has blue color on the bars. Then you can see the border. It has some dark lining. Okay. Then we now want to add maybe the title for our graph. We want to name the y-axis also. So to do that, to name your axis and your title, you'll say labs to stand for labels. Then inside the bracket, you name your x, what you want it to be named. Say I want to name it as race. Then I'll name my y-intercept. Say I want to name it as, I'll name it as frequency. Then I'll want to name my title. I'll want to give it a title called participants of race, but how can I name it? I'm studying about the race, so I'll name it participants by race, participants by race. Then I'll run that and see what the outputs are. You can see now our graph now has a title and it has a y label of frequency